Because we're asked to use n rectangles, we're just solving for Rn in general. We're not solving for R5 or 8 or anything. It's Rn. And we want to use n rectangles, which means when we do our process, we start with xn. Delta x equals 5 minus 3, or b minus a, over, and now we just have n. So this is equal to 2 over n. Now we're calculating our xi's, and we're going to be using left-hand approximation for our xi's. So because we're using our left-hand approximation, this is a plus I minus 1 delta x, or equal to, xi is equal to 3 plus I minus 1 times 2 over n, which is equal to
Attention all active passengers. Once again, attention
3
all active passengers.
plus
Use the platform restriction.
2i
Not all
over
coaches
n
open at active go.
minus
If you're in
2
coaches
over
2700,
n.
4005, 4017,
Now that we have our xi, we calculate our
2317, please
f
walk in the direction
of
the train
xi.
is dropping it.
F of xi
Coach
is equal to
2504 to exit at active go. Once again, the coaches are 2700, 4005,
xi
4075,
squared
and 2317. Please make your
minus
way in
2
the direction the train is dropping it until you pass successfully.
f of xi is equal to 3 plus 2i
Additional wall central
over n
passengers. Once again, attention all wall central passengers.
minus 2
The street will
over
not
n
open at 12 Central. If you're in coaches 2056,
times
2762, 22
2 minus 2 over n
2050, 4190, and
squared
337. Please
minus
walk in the opposite direction as
2.
the train is dropping it. Until you pass successfully.
Then
25.
the last thing we need to do is we need to calculate what Rn is in sigma form.
2762.
So we now need to take into our account the sigma Rn.
4190 and 337.
I'm going
Please make your
to
way in the opposite direction. The train is dropping it.
insert a space here
Coach 2504 to exit at 12 Central.
on insert
Our next
space.
stop is Georgetown.
Insert space. Oop, it's not letting me insert space, so we're just going to continue on here. We have the sum of Rn equals the sum of I equals 1 to n f xi times delta x, which is equal to the sum I equals 1 to n of 3 plus 2i over n minus 2n squared minus 2 all times 1 over n. And at this point, we can leave it if we would like to answer A. Just to note, there's one little error from last time. This should be a 2 over n. But otherwise the process is the same. Now what we're going to do is we are going to convert to add, to solve for part B. And part B, we want to go to closed form. So now we do need to expand this square term and expand everything out so that we can implement our closed form, which will be slightly a pain. We have to be very careful when we do this, but it's not too bad. So it's going to be a lot of just manipulations. Rn equals sum of I equals 1 to n of, and now we have 3 times 3 is 9 plus 6i over n minus 6 over n plus 6i over n plus 4i squared over n squared minus 4i over n squared minus 6 over n minus 4i over n squared plus 4 over n squared minus 2 all times 2 over n. Now this might seem pretty ugly, but what we're going to do is we're going to collect them by the powers of I. So Rn equals the sum of I equals 1 to n. Now anything that has I squared we're going to collect first. So it's going to be, and that's just 4 over n. So 4 over n I squared. 4 over n squared, I squared. And then this here, everything here is, all these terms are all multiplied by n over 2. So we're going to also multiply this by 2 over n plus. Now we're going to the sum of I equals 1 to n. And we're going to do anything multiplied by I. And we're going to put all of those in a bracket. We're going to move this I much further back, allowing us to collect all those things. And what we're given is we're given 6 over n plus 6 over n minus 4 over n squared minus 4 over n squared all times 2 over n. And now, last but not least, we're going to collect our sum of I equals 1 to n. And these are the terms that aren't multiplied by any I. So we've got 9 minus 6 over n minus 6 over n minus, whoop, let's get back, minus 6 over n minus 6 over n minus 2. This is all times 2 over n. And we've collected all our terms now. And now what we're going to do is we're going to simplify our expression. So this equals 8 over n cubed. Sum of I equals 1 to n I squared plus, here 2 6 over n's give me, and we're multiplying by 2 over n, so that's 12. So we have 2 over n times 12 over n minus 8 over n squared times the sum of I equals 1 to n of I minus, here we got 9 minus 2, which is, we still have that 2 over n multiplied by 9 minus 2 is 7 minus 12 over n times the sum of I equals 1 to n 1. And at this point, what we can do is we can replace the sums with their equations. So R of n equals 8 over n cubed times 2n plus 1 n plus 1 n over 6 plus, and now here we've got 2 over n, 12 over n minus 8 over n squared times plus 1 all over 2 minus 2 over n times 7 minus 12 n times n. And we have our closed form. We could simplify further from here, but this is all we need to do. Again, what are our steps? Our steps are isolate for each term, I squared, then I, then 1. Factor out anything that isn't I outside of the sum, and then apply our rules. Just going to zoom out just a little bit more so we can gain all of those ideas together. And I'm going to stop recording.
Should I like add them?
So part C now asks us to take our expression for Rn and take the limit as n goes to infinity. So we're taking the limit as n goes to infinity of Rn, and now what we can do is we can take the limit of each of these pieces. Not only that, we can distribute this and take the limit of the distributed pieces. So we can take the limit as n goes to infinity of our first term plus the limit as n goes to infinity of our next term plus the limit as n goes to infinity of our last term. And what's really nice is this first term we can see is going to be equal to 8 over 3. The second term, this piece here, when we expand in, is going to give us a limit of 12. And this piece here, when we expand in, is going to give us a limit of 0. So combining them, we get a limit of 12.
This is your final reminder.
Finally, here, when we take this limit and we expand it in, we get a limit of minus 14. Whereas this piece here, when we expand everything over, it's also going to give us a limit of 0. So we're going to get 8 over 3 plus 12 minus 14, which equals 8 over 3 minus 2, which equals 2/3. We have our error. Just want to note that there was a small error in what I did. There should be a plus here, not a minus, which means this is a plus, which means we're not subtracting by 14, we're adding by 14. When we're adding by 14, this doesn't give us subtract 2. This will actually give us 68 over 3, not 2 over 3. And if we compare to the answer that when we take the integral from 3, definite integral from 3 to 5 from above, we get that answer of 86 over 3. So, sorry, not 68, but 86 over 3. So just an update about a sign error that I made along. And what's nice about this exam or this quiz, which might be helpful for future quizzes, is that the answer we're asking you, the question we're asking you to find the antiderivative of, using this infinite sum. We also ask you to calculate the antiderivative of using the fundamental theorem of calculus earlier on in the